So this lesson will be topic 3 of unit real numbers, radicals, and rational exponents. And in this lesson, students will be able to rewrite expressions involving radicals and exponent properties, using exponent properties, explaining how the definition of the meaning of radical exponents follows from extending the properties of integer exponents to those values, allowing for notation for radicals in terms of rational exponents. We write expressions involving rational exponents using exponent properties, apply the properties of integer exponents to generate equivalent numerical expressions. Now, let's talk about radical. So a radical is that symbol that you're looking at. And as you can see, it has two essential parts, even three: the symbol, an index, and the radicand. The index is a number that is going to be outside of the radical, and the radicand is going to be an expression, positive, negative, integer, fractions, and any number, or sometimes includes decimal, sometimes include variables, multiple variables. So the radical, it has the symbol, the index, and the radicand. And also keep in mind that the index is always a natural number. Index is always a natural number. Okay, so now, as I mentioned earlier, not all radicals have the index. As you can see, the first one has no index. So keep in mind, no index means index equals 2. And with no index, the symbol is read square root. So the square root of A equals B means A equals B squared. Example, square root of 4 equals 2 only because 4 equals 2 squared. Now with the index 3, the radical is read cube root of. So in this example, we're going to say the cube root of A equals B. And that means A equals B to the third power. Example, the cube root of 8 equals 2 only because 8 equals 2 to the third power. The next example, we have fourth root, we have the index that is 4, and then the way you read with an index 4 is the fourth root of, and the example, fourth root of A equals B means that this number A equals the number B raised to the fourth power. A concrete example of that is the fourth root of 16 equals 2. And the reason why fourth root of 16 equals 2 is because when you raise 2 to the power 4, it equals 16. And then you can keep on going for any other number. Keep in mind, the index is always going to be a natural number. So n is always going to be positive and an integer. You're going to say nth root of A equals B means that A is B raised to the nth power. Now let's get started, and we're going to start with the square root. And to have a good start with simplifying square roots, you're going to need to know most of your perfect squares. I will say the first 10 perfect squares from 1 through, well, at least let me say the first 20 perfect squares from 1 through 20. So what you're going to do is, in the next slide, you're going to see a list of the squares from 1 through 20. Use your calculator in your notebook. you're going to start writing down, and while you're writing down, see how you can memorize all the perfect squares from 1 through 20. So 1 square, 1 squared, 2 squared, 3 squared, and all the way to 20. Go. You're gonna have this time, pause your video, and get your numbers ready.
So feel free to pause the video and try these problems, and then unpause it when you're ready. So let's start with the first one. What perfect square goes into 27? We know 9 goes into 27. 9 times 3 is 27. And the square root of 9 is 3. So this simplifies to 3 root 3. Now what's the highest perfect square that goes into 48? 4 goes into 48, but the same is true for 16. So if you start with the highest perfect square, it's going to make simplifying it a lot easier, especially when you're dealing with larger numbers. 48 divided by 16 is 3. So the square root of 16 is 4. So this simplifies to 4 root 3. What perfect square goes into 128? 128 is 64 times 2, and the square root of 64 is 8. Now what about 450? This is 225 times 2, and the square root of 225 is 15. And for root 98, that's 49 times 2, and the square root of 49 is 7. Now what about 1200? What's the largest perfect square that goes into 1200? This would be 400. The square root of 400, well, 3 times 400 is 1200, and the square root of 400 is 20, so you get 20 root 3. So that's how you can simplify perfect squares.
So now the same thing we did for the square root, we're going to do it for the cube root. The only thing, instead of doing 1 through 20, we're just going to do the cube of 1 through 10 and then try to memorize them just like we did for the square root. So you're going to calculate 1 cubed, 2 cubed, 3 cubed, and all the way through 10. Go and make sure you memorize them. You can use your calculator to do so. And I would advise that you pause the video, calculate your cubes, and start it when you finish.
We're going to go over the perfect cubes at least up to 10. So 1 to the third is 1, 2 to the third is 8, 2 times 2 times 2 is 8, 3 cubed, or 3 times 3 times 3 is 27, 4 to the third power is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 to the third is 1000. 10 times 10 times 10 is 1000. So let's say if you want to find the cube root of 16. What is the highest perfect cube that goes into 16? Well, it's none other than 8. 16 divided by 8 is 2. So you want to rewrite cube root of 16 as the cube root of 8 times the cube root of 2. And the cube root of 8 is 2, because 2 to the third power is 8. So this simplifies to this answer. So go ahead and try these examples. The cube root of 54, the cube root of 192, and the cube root of 375. So 27 goes into 54, and 27 times 2 is 54. And the cube root of 27 is 3. So this is 3 cube root of 2. Now what number goes into 192? You can take each perfect cube and see which one is divisible by 192, and pick the largest of them. 8 goes into 192 and 64, but we're going to choose 64. 192 divided by 64 is 3. So when you split it, it's going to be 64 times 3. And the cube root of 64 is 4. So we get 4 cube root of 2. Here we have 375. Because there's a 5 in it, chances are it's divisible by 125. So 375 divided by 125 is 3. And the cube root of 125 is 5. Oh wait, was supposed to be a 3. So that answer was supposed to be 4 cube root of 3. I don't know why I put 2. Maybe I got in the habit of writing 2's. Try these two. The cube root of 1024 and the cube root of 5000. So the largest perfect cube that goes into 1024 is 512. 512 is half of 1024. So we can rewrite this as 512 times 2. And the cube root of 512 is 8. So this simplifies to 8 cube root of 2. For this one, 5000 is 1000 times 5. And we know the cube root of 1000, that's 10. So we get 10 cube root of 5. Now,
Remember the same thing we did for square root and cube root. Now let's do it for the fourth root. So we're gonna start by calculating the first 10 perfect fourth. Put them down on your paper and try to memorize them. You can use your calculator. Now I want you to pause the video, write them down, and then try to see if you can memorize at least the first 5, but try to memorize some of them that can help you as you're performing your fourth root. Go.
3 to the 4th is 81. 4 to the 4th power is 256. 5 to the 4th power is 625. And 6 to the 4th power is 1296. So let's say if we have these 3 problems, the 4th root of 32 and the 4th root of 162 and the 4th root of 768. So feel free to pause the video and try these practice problems. So which of these numbers go into 32? Clearly it has to be 16. 16 times 2 is 32. And we know the 4th root of 16 is 2. So we get 2 4th root of 2. And 81 goes into 162. So we have the 4th root of 81 times the 4th root of 2. And the 4th root of 81 is 3. So we get 3 times the 4th root of 2. Now which number goes into 768? Let's see. 768 divided by 81 is a decimal answer, so that doesn't work. 768 divided by 256 is 3. So we can rewrite this as the 4th root of 256 times the 4th root of 3. The 4th root of 256 is 4. And that's the answer we get for that problem.
So now, how do we solve radicals when variables are involved? How do we simplify radicals while some variables are involved? Let's try some examples.
Simple. How would you simplify the square root of x to the 3rd? Now keep in mind there's a 2 here. One way you can do this is you can split it to the square root of x squared times the square root of x. The square root of x squared is just x times root x. Now depending on the algebra course that you're taking, some teachers will want you to put an absolute value. If you have an even like index number, and if you get an odd exponent, some teachers may want you to put it in an absolute value. Other teachers, they may not focus on that concept, but depending on the course you take, I'm going to add the absolute value, just so you know when to do so. So let's say if you have the square root of x to the 7th. Here's another way you can do it. How many times does 2 go into 7? 2 goes into 7 3 times, so it's going to be x cubed, and then with 1 remaining, x to the 1. Another way to show your work is you can separate it as x to the 6 times the square root of x. Here, this is a 2. 6 divided by 2, you can rewrite that as x 6 over 2, which is x to the third times root x. But I'm going to stick to one method. So let's say if you want to find the square root of x to the 9. How many times does 2 go into 9? 2 goes into 9 4 times, with 1 remaining. So let's say if you have the cube root of x to the 13. How many times does 3 go into 13? 3 goes into 13 4 times, with 1 remaining. But this time you got to put the 3. Let's say if you have the cube root of x to the 11. How many times does 3 go into 11? 3 goes into 11 3 times, because 3 times 3 is 9. And the difference between 11 and 9 is 2. So 3 goes into 11 3 times, with 2 remaining. So using what you know, go ahead and try these practice problems. Find the square root of x to the 5th, the cube root of x to the 17th, the fourth root of x to the 15th, and the seventh root of x to the 19th. So let's begin. How many times does 2 go into 5? 2 goes into 5 2 times, because 2 times 2 is 4. And 5 minus 4 is 1, so the remainder is 1. Now how many times does 3 go into 17? 3 goes into 17 5 times. 3 times 5 is 15. 3 times 6 is 18, which is too much. So it goes into 17 5 times. And 17 minus 15 is 2, so we have 2 remaining. But we got to write the 3 here as the index number. How many times does 4 go into 15? 4 goes into 15 3 times. 4 times 3 is 12. And 15 minus 12 is 3. So the remainder is also 3. Now how many times does 7 go into 19? 7 goes into 19 2 times, because 2 times 7 is 14. And 19 minus 14 is 5. Do you see the pattern? That's the quick way to get the answer. But remember, if you want to show your work, let's focus on this one. What you could have done is you can rewrite it as square root of x to the 4th times the square root of x. And 4 divided by 2 is 2, so you get x squared root x. Now for this example, what I would have done, if you want to show your work, I would split it to 15 and 2. The cube root of x to the 15 times the cube root of x squared. 15 plus 2 is 17. But 3 goes into 15 5 times evenly, because 15 divided by 3 is 5. So that's how this turns out to be an x to the 5th cube root x squared. For this one, I would break it into the fourth root of x to the 12th times the fourth root of x to the 3. 12 plus 3 is 15, but 4 goes into 12 evenly. 12 divided by 4 is 3. So then you'll get this answer. And for the last one, I would rewrite it as the seventh root of x to the 14th times the seventh root of x to the 5th. 14 divided by 7 is 2, so you get x squared times the seventh root of x to the 5th. So now that you understand how to simplify radicals when there's a variable inside, let's put everything together. Let's say if you want to find the square root of 50 x cubed y to the 5th. Feel free to pause the video and go ahead and simplify it. So there's a 2 here. So I'm going to use the technique where we're going to separate the radicals and then simplify it. A perfect square that goes into 50 is 25. So 50, I'm going to write it as square root 25 times square root 2. And x cubed, I'm going to write it as the square root of x squared and the square root of x. Y to the 5th, I'm going to write it as the square root of y to the 4th times the square root of y. So there's an invisible 2 here. So I had to separate the even values from these odd exponents. The square root of 25 is 5, and the square root of x squared is x, and the square root of y to the 4th is y squared. Now, if you need to add parentheses, I probably didn't add it for some other examples, but if you want to add it here, you would add it to this one because it has an odd exponent. And then everything else that can't be simplified, collect it and put it inside a single radical. So the square root of 2xy. That's the answer for that example. So let's try another one. So let's say if you want to find the square root of 72 x to the 4th, y to the 5th, z to the 6th. A perfect square that goes into 72 is 36. So we're going to write this as the square root of 36 times the square root of 2. So 2 goes into 4 evenly, so I'm just going to rewrite it as the square root of x to the 4th. For y to the 5th, it's an odd number, so I'm going to write it as y to the 4th times y to the 1st. It adds up to 5. And then z to the 6th, I'm going to leave it alone. The square root of 36 is 6. The square root of x to the 4th is x squared. Because the exponent is even and not odd, we don't need an absolute value. The square root of y to the 4th is y squared. And the square root of z to the 6th is z to the 3rd. So we have an even index, an odd result, so we're going to put this in an absolute value. Then every other term that wasn't simplified, in this case the 2 and the y, we're going to put it inside the radical, so 2 times y. So that's the answer for that particular problem. So now let's try a cube root. So let's say if you want to simplify the cube root of 24 x to the 6th, y to the 7th, z to the 10, r to the 13. So what perfect cube goes into 24? 8. So 24, we're going to rewrite it as the cube root of 8 times the cube root of 3. And 3 goes into 6 evenly, so we're just going to keep it like that. Cube root of x to the 6th. 7 doesn't go into 6 evenly, but 6 does. So we're going to write it as the cube root of y to the 6th times the cube root of y to the 1st, because 6 plus 1 is 7. 3 doesn't go into 10 evenly, but 3 goes into 9. So I'm going to rewrite it as the cube root of z to the 9 times the cube root of z to the 1. And times, let me add it here. 3 goes into 12, not 13, so cube root of r12 times the cube root of r to the 1st. 1 plus 12 is 13. Okay, let's simplify the radicals that can be simplified. The cube root of 8 is 2. And here, 6 divided by 3 is 2, so that turns out to be x squared. If you have an odd index, there's no absolute values that you have to write for this. Now this one, 6 divided by 3, that's also y squared. We could simplify this one. 9 divided by 3 is 3. And 12 divided by 3 is 4. So we get r to the 4th. Everything else is going to stay in the cube root. So we have a 3, we have a y, we have a z, and we have an r. And so this is the answer for that problem. So now let's try a fourth root. Let's say if we want to find the fourth root of 32 x to the 7, y to the 12, z to the 15, r to the 20. So what number goes into 32? That's a fourth root. In this case, 16. So we're going to rewrite this as the fourth root of 16 and times the fourth root of 2. Now 4 doesn't go into 7. 4 goes into 4, and 4 plus 3 is 7. So we're going to write it as x to the 4th times x to the 3rd. 4 goes into 12, so we're just going to rewrite it as that. 4 doesn't go into 13. It goes, the highest number that it goes closest to 15 is 12. So we're going to write it as z to the 12 times the fourth root of z to the third, because 12 and 3 is 5. Now 4 does go into 20, so we're just going to leave this alone. So now let's simplify. The fourth root is 16. What number times itself 4 times is 16? 2 times 2 times 2 times 2 is 16, so the fourth root of 16 is 2. Next, we could simplify this. 4 divided by 4 is 1. So we have an even index number and an odd exponent. So we're going to put that in parentheses in absolute value. The fourth root of y to the 12 is y to the third. And the fourth root of z to the 12 is z to the third. And the fourth root of r to the 20 is r to the fifth. So we can put this whole thing in an absolute value. So everything else, we're just going to collect it now inside one radical. So we have a 2, we have x cubed, and we have z to the third. And that's our answer.